Transformation of trigonometric functions. So here we are given a function f of x equals to sine of 2 times x minus 30 degrees. And you need to find all these characteristics of this transformed function. So my suggestion is write down your answers and then look into my solutions or hints. Question 30 is to find time period. Question 31 is to find y-intercept. 32, first two x-intercepts are at the location of first two x-intercepts. Question 33 is range of the function. Question 34 is maximum of f of x is at. And 35, value of minimum of the function f of x is what? So answer these and then look into my suggestion. Now we can do our calculations to figure out all the answers. Now that is how I'm going to do it now. Time period of f of x is, time period is 360 divided by 2. So the time period is 360 degrees divided by 2 and we get 180 degrees. So that is the time period for us. Y-intercept of f of x is, for y-intercept we need to put 0 for x and then calculate the value, right? So y-intercept is basically f of 0, right? The value of the function when x is 0, that is y-intercept. So we get sine of 2 times minus 30 degrees, do you see? And that gives us sine of, minus means minus sine, correct? And sine of 60 degrees. So that is the answer, that's the value, right? Sine of 60 degrees. To find this, we can make our special triangle. And the triangle is 30, 60, 90. So in a 30-60 triangle, we have the sides as 1, 2 as a hypotenuse and opposite side is square root 3. And therefore, the answer is minus square root 3 over 2. So that is the y-intercept. At 0, the value is minus square root 3 over 2. First two x-intercepts are at. Now, the value of x-intercepts you can also find with the help of transformation of the points. That could be an easy approach here, right? Now, as you know, the value of x-intercepts for a sine function, normal sine function. Let me sketch one and show you what I'm trying to say. Normal sine function will be like this. That's right. So the x-intercepts for us are at these points, which are 0 degrees, 180 degrees, and 360 degrees. So these are my x-intercepts for sine x, right? Now how about sine of 2x? So when we do sine of 2x minus 30, the transformation takes place like this. This is my original x and y points, right? And they get transformed. And in this case, y remains same, but x is getting changed, right? How are they getting changed? They get half of it multiplied by half, and then minus 30 means move it right. So add 30. So half of original x value plus 30 degrees. So that is the change in x, y remains same. So this is the transformation, right? So therefore, if you do this, then for the x point, x-intercept is at x equals 2. First is at 0. Half of 0 is 0 plus 30. So we get 30 degrees. So that is the first one. And the second one will be half of 180, which is 90. 90 plus 30 is 120 degrees. So we get 120 degrees. So that is the best way of finding x-intercepts, right? Consider image of the transformed point. Now range of f of x is. So for range, we know the y values remain same. So the range really doesn't change, right? So range is same. So it is from minus 1 to plus 1, correct? Maximum of f of x is at. Now normally the maximum of sine of x will be at 90 degrees, right? But now we know it gets transformed and it is half of 90. This time let me do the calculation here. So it is half of 90 and then plus 30 degrees, right? So that is our answer. So 45 plus 30 means 75 degrees, right? So that is the location of maximum, the first maximum. Value of minimum of the function is, as we have seen, minimum is same as in the original sin x function, and the value of minimum is -1. So these are the answers for this question. Now I'll recommend that the next question is very similar, very similar. So I'd like you to read the question, copy it down, and answer it yourself. That will give you some confidence, right? Now the next question is very similar, but with a very important change. I'll appreciate if you could identify that change and then answer it correctly. Thanks and all the best.